Some numbers are just more magical than others, and in chemistry there are certain numbers with more symmetry and more stability than others. Understanding this phenomenon is going to help you utilize the periodic table in a way where you are no longer just memorizing the trends and properties of the elements, you're going to actually understand why they are what they are, and also appreciate a little bit of the mysticism and magic behind certain values and why they've held such strong meanings to scholars and spiritual people for thousands of years. Guys, welcome back to GCSE Minecraft and Chill, the series where I'm talking at you and playing Minecraft to entertain myself and maybe you with the stories behind the science and maths you need to know for your exams that fascinates me. I hope you're having a lovely day, that you've got a drink and something to do while I chat at you. We're kind of carrying on the story from week 3's chemistry video where I went into some detail on the connections between alchemy and the periodic table and the development of our understanding of the elements and their behaviours. And this time we're going to think a bit more about the magic behind the periodic table and why I find it so interesting and how you can use it to upgrade your skills in chemistry. Now, don't panic, but we are pivoting to numbers, maths in a chemistry video, yes, specifically numerology, and I am no expert and I'm not particularly well read in this branch of the occult, and it's important to be respectful as pretty much everything in the occult you can trace an origin back to Judaism. So if you're interested in the occult and the adjacent topics like I am, be sure to brush up on what anti-Semitism is, how it pervades society, and how European colonialism has stolen knowledge from the global south for centuries. Of course, I'm going to link a couple of sources below, but it is crucial that you do your own research on this, as no one source will encapsulate such a complicated topic, especially with the way that the interest in the occult has just exploded in the global north over the last 30 to 50 years. But anyway, how does numerology relate to chemistry? Don't worry, we are going to get there. First, numerology, as it's often called nowadays in the English-speaking world, was originally referred to as gematria, and it was the practice of assigning alphanumeric values to Hebrew letters and then calculating a specific number associated with the name of something in order to divine some truth about the nature of whatever that thing was. And of course, that's a massive simplification, and the practice was a lot more complex than that, more nuanced than that, and of course it has evolved and changed in different cultures and parts of the world like Egypt, Greece, Southwest Asia, and China. And if you caught my video about algebra this week, we explored a little bit more about some of the transfers of ancient knowledge in that video, so check out that one as well if you're interested in that little bit of science history. Anyway, numerology or gematria, I'm going to be using those terms interchangeably in this video, has a similar story for how algebra made its way from the global south to the global north. So, like astrology, gematria was considered equally as academic and important a pursuit as alchemy, mathematics, geometry, and philosophy. Royals and leaders respected the scholars that could practice divination, understand and interpret, and then explain the world around them, especially if that helped them make predictions for things. And whatever tools the ancients had at their disposal, they made use of, and divination with some of the patterns that presented themselves in the natural world was and actually still is a fantastic tool for people to explore their lives today, either to solve problems, find meaning in a challenging situation, seeking guidance on future decision making, or interpreting the patterns revealing themselves in your workplace, in relationships, in our own psyches, or even in global international systems like the stock market, right? Tarot and astrology are the modern, incredibly popular divination tools a lot of people are familiar with in the UK and prefer to use as an esoteric way of making sense of the world around us, but there are lots and lots of them. It feels like it's a natural human impulse to do some form of divination, and I love that. Our brains, like our fundamental biology, is geared towards pattern recognition, simplification, stability, and endurance. And natural patterns were the fundamental phenomenon that I feel originated a lot of the scholarly investigation and guided ancient gurus and spiritual scholars and scientists to either feel some kind of inspiration in the right direction or to deduce the incredible conclusions that shape the fields of knowledge that help us understand the world today. Pattern recognition is still a really important skill for scientists to make sense of data, analyze results, and interpret meaning in those results to draw conclusions, right? So numbers and repeating patterns are just deeply entwined with nature. Symmetry, spirals, and coincidental quantities seem to crop up and repeat themselves time and again, and that is just straight up magic to me, and I truly wish I had more time on my hands to read deeply into the study and writings of gematria and the Jewish Kabbalah. I do actually have a couple of books on my to-be-read list on the subject, but they have been there for a good couple of years now. Hey, don't judge me. All right, I am going to get around to them eventually. And maybe actually when I do, I'll come back and make a follow-up video to this on this topic, because I do super love talking about it. But anyway, for now, I'm going to stick with some of the connections that I already know about and like talking about. So a few really well-known numbers, or at least a few of my favourites, including ratios and patterns that exist in nature, that I think are worth mentioning at this point are pi, of course, the ratio between the circumference and diameter of a circle, the Fibonacci sequence, where you just add each number to the last to get the next number, which produces a gorgeous logarithmic spiral pattern when you plot it, which is found everywhere in nature, and symmetry or repeating tessellating patterns of shapes or numbers like scales and flowers and sea creatures. They're things that tend to favour fivefold symmetry, for example, or the bilateral symmetry we're really familiar with in animals, or even something like fractals. You can see in how tree branches spread out and repeat themselves. There's just so many examples. I could go on and on. There are just natural geometric consequences to certain aspects of life that come down to how matter is constructed at the atomic and molecular level. So a paper that I will link below, or an article talking about the paper, about how scientists have shown that symmetry in life tends to be a consequence of how DNA is constructed, and the fact that it's just easier and more resource efficient to repeat a set of instructions a certain number of times rather than to individually try to code everything. And if we bring that to chemistry, I told you we would make the link soon enough, when we're considering how electrons and atoms behave rather than resource efficiency in terms of replicating proteins for DNA, or the instructions that the DNA gives a living thing, the resource that we have in short supply is energy. And it helps to understand quite a lot of scientific phenomena if you think about these things in terms of either trying to increase or decrease the amount of disorder or spread of energies happening in any given system. And the fancy name for that is entropy, but I'm not about to make this a physics lesson. We've already done some maths. All you need to know is that atoms and electrons are often trying to minimize the amount of energy that they need to keep themselves stable. And what does this all have to do with numerology that I was chatting about? Well, it's because, like the title suggests, the magic number for the periodic table is 8. In gematria, 8 just so happens to represent new beginnings. Since God made the world in 7 days, the 8th day was the fresh start of a new week. So the repeating pattern of the periodic table is that you get a new period after 8 groups. And that has just always struck me as quite a pleasing coincidence. There's this underlying logic behind atoms favouring twofold symmetry because of the opposing nature of an electron. They like to exist in pairs, and if they have to coexist with other electrons at all, that is, they tend to favour the multiples of 2, so we tend to have this twofold symmetry, and we get stability when there's multiples of 2. And of course 8 is going to be the maximum amount of electrons in a standard electron shell, while maintaining an equal amount of repulsion between 4 pairs. So we see the periodic table get built up in terms of 4 pairs of 2 electrons, because, and then you also see each multiple of 2 is slightly more stable than the odd numbers that precede them. But yeah, because that's how you learn. You've got the initial 2 electron shell, and then you have 6, so 2 and 6, and they make 8 together in terms of orbitals. I don't actually think you learn that until A level, but standard electron shell, 8 electrons in it, all right? So that's 4 pairs, and 4 in numerology, in Kabbalah, in tarot, the esoteric and occult, represents stagnation, limitations, practicality and pragmatism, like the 4 corners of the world, the 4 cardinal directions. The literal perpendicular nature of a cross indicates stability. Literally, it's stable because you can't push either of the sides of the cross in one direction without bumping past the line going in the crossing over in the other direction, right? So it represents the maximum resistance to motion at a 90-degree angle. And if you advance your mathematics studies and study mechanics, you'll understand why that is, or your physics. But here's sort of a little analogy to think about it. If you're traveling in a certain direction, if you're moving north and then you start increasing your angle away from the north direction, so clockwise, like the hands of a clock going round, you can only go so far before you would describe yourself as moving northeast, and only go so far further in that direction before you're not going north at all anymore. If you keep increasing your angle, you'd be going east. And that's kind of what's happening to the electrons around the nucleus. If you're trying to get them to have maximum repulsion between them, there's only so many angles of the circle that they can occupy before they're interacting with the pushback that's going to be coming from another pair of electrons at another point on the circle, right? So the 4 pairs of them on the cardinal directions, it doesn't really matter as long as they're 90 degrees apart, that's what represents the maximum distance between one another that's possible in the circular conception of the electron shell that we have. Any more than that, any more than 4 pairs, and you'll be experiencing some unequal resistive or repulsive forces is going to upset that symmetry and cause imbalance or instability one way or the other. So each of the 4 pairs in a full shell occupy the cardinal directions happily without encroaching on one another's electrical territories and causing instability overall in the atom. And so bringing us back to the number 8, it is the number of success, achievement, abundance, cycles, particularly material nature, like cycles that are material in nature, or success and abundance or achievement that is material in nature. It's some culmination of hard work and effort manifesting materially. And if you think about it that way, you can see that analogously, the atom's attempt to fill a shell with 8 electrons is the culmination of the effort exerted by the positive charge of the nucleus. So if an atom only has 1 or 2 electrons, the effort exerted to simply eject those electrons to have an empty shell, rather than the effort exerted to add 6 or 7 electrons into the shell, is much lower, and hence the metals in groups 1, 2, and 3 tend to eject their electrons and become positively charged cations, and hence why group 1 is more reactive than group 2. The effort is so much lower to eject, not inject, eject, literally the opposite, eject 1 electron rather than 2, and it happens more easily and readily, making those cations formed more easily, and hence the elements in group 1 more reactive in general than group 2. Whereas on the other side of the table, groups 6 and 7 are so close to completely filling their shell with 8 electrons that they readily, almost greedily and easily snatch up any free electrons wandering about to fill their shell and get that stability, because the effort of doing that is significantly less compared to the effort of ejecting all 6 or 7 electrons back to an empty shell to rid themselves of the instability of not having that perfectly symmetrical 4-pair shell. And this pattern does repeat itself in a similar way with the transition metals, depending on how many electrons they have in their shell of 10 electrons, but that's more complicated and for A-level students to worry about and for GCSE students to take for granted. We see a similar thing, but we're not dealing with 4-fold symmetry in that case. But regardless of the model and the analogy and the comparison, I really can't understate how important this concept of stability, repeating patterns, and the concept of electron pairs is to understanding chemistry, and why this 2-fold symmetry is just all over the place, and sort of the more multiplicity you have of 2, so 4 is 2-fold multiplicity of 2, right, and then 8 is 3-fold, you've got 3 2s, 2 cubed is 8, and that explains a lot of the patterns that you see in chemistry, as well as other trends. So other trends in the periodic table you need to be familiar with are things like the melting and boiling points, and which elements tend to form ionic versus covalent bonds, and the trends of reactivity within each individual group. So let's think about understanding these trends without just memorizing the answers. I would say ask yourself what energy is required to make a given thing happen, and what would be the lowest energy way of making it happen. Atoms want to work smarter, not harder, right? For melting or boiling a substance, you're breaking bulk intermolecular bonds of a substance, right? We're talking about a bulk property here, not a microscopic property. And the compounds that tend to have the strongest intermolecular bonds are what? The compounds with the strongest overall bulk structure. Well, it's going to be the one whose electron shells are overlapping and sharing. So this is, the cohabiting covalent partners. So this is going to be substances like diamond, which do have pretty high melting and boiling points. The giant covalent structure, the strongest structure. And then just beneath them, we have giant ionic structures. The the sharing of an electron and then electrostatically sticking together is quite a strong bulk bond. Then just below that we have metals, which are bendy and tough, pretty tough to melt. And then below that, the lowest, we have simple covalent molecules that do tend to be gas at room temperature, just because their bulk structure is basically already separated. It's already individual little molecules that want to be apart, and that's just all it gases, right? It's just talking about how stuck together the different atoms or molecules within a compound are. And if they're in simple molecular structure, they're already separate, so it's quite easy to separate them. Whereas water has something else going on in its simple molecular structure that's sort of sticking the molecules in their intermolecular bonds closer together, so it's a little bit harder to turn it into the gas form. So thinking about it like that and understanding that it's looking for the lowest energy way to exist and what puts in the least amount of energy, it kind of makes sense, right? But you have to know which elements are going to form the ionic, covalent, or metallic bonds. And again, you can look at the periodic table and get the trends in your head, understanding them, of who wants to get to an empty or full shell most easily. That's going to be groups 1 and 7, so they're going to form ionic bonds because they're going to get rid of their electron, become charged, and then stick to each other with their opposite charges. That's going to be logical that would be group 1 and 7, right? If you understand about the repeating pattern of 8 and the full shell. Whereas look at groups 4 and 5, they're in the middle. They tend to form the covalent bonds the most often because that's easier for them to get a full shell of electrons if they decide that they're going to share them. For example, think about carbon. It's in group 4, it's got 4 electrons in its outer shell. What is it going to do? Lose 4 electrons or gain 4 electrons? It would literally rather do nothing. That would be the lowest energy thing for it to do. So if you've got a couple of eager oxygens coming along who just want 2 more electrons to fill their shell, and carbon would rather not hand over just 2 of them, that wouldn't be very symmetrical, but it can compromise, and they do a sort of timeshare arrangement where they each get something. So we get CO2, where each oxygen is sharing 2 pairs of electrons with a carbon atom in the middle. And then consider metals. Metals are just kind of doing their own metallic thing. They have their own system going on. There's no giving and taking or sharing. They just have a communal, take it as and when, delocalized system because that's the lowest energy model for them, a sort of in-betweeny model. And the last point I was talking about was reactivity within a group. Let's think about those patterns. So think about what takes the least energy within a group. They're trying to get rid of or gain an electron. They're going to be trying to do the same thing within the group because they're in the same group. So the energy or force making that thing happen is the balance of the negative charge of the electrons repelling each other to either get rid of each other, or the positive charge of the nucleus attracting an electron into the shell. So think about what happens as we go down a group. We have more periods, we have more electron shells full of electrons. That means a lot more repulsive force, which means getting rid of electrons is going to be easier and gaining electrons is going to be harder because it's surrounding that positive charge in the nucleus that's in the middle. And so there we have it. The bottom of group 1 is going to be the most reactive because it's getting rid of electrons, whereas the top of group 1 is going to be the most reactive because it's gaining electrons. And that's just kind of always how I've remembered it anyway. There's so many interesting numbers and patterns in the periodic table, and I could talk about my favourites like silicon, iron, copper, or uranium for hours, or why certain constants appear in famous scientific equations and why they are the way they are. Like, what is it about circles that means that pi is roughly 3? What is it about 3? Why roughly 3? I highly recommend, if you're into stuff like that, that you watch YouTube channels like Numberphile or Standard Maths if you have, if you want to know answers to questions like that. Because the coincidences of numbers in nature has always fascinated scientists, scholars, and spiritual people, whether there's some grand numeric design to the universe or simply a natural order that can be divined through pattern recognition and innate curiosity. Whichever way, I think it's pretty amazing. and I love stumbling across these little universal coincidences. So I hope you enjoyed this episode, and I will leave you as usual with a reminder that your words are spells, so always be kind to yourself and be intentional with others, and have a lovely rest of your week. Again, thank you for being patient with me this week while I took a break and was uploading a bit irregularly and all over the place. See you next time. Yalla bye.